Good morning everyone. Today's lesson is about dimensioning. Now, just similar to British standards, there are information in these slides that you would have learnt in National 5. However, there are a lot more terms that you will need to know. So I expect you to take notes. Again, in your National 5 jotter or any paper or anything that you have, because we will not be going over it again when we are in school. So why do we need to add dimensioning? So dimensions are giving you the sizes in order to manufacture the product. So the manufacturer needs to have this information in order to make the components to the correct size so that they can be assembled correctly. Now, in the UK and other parts of the world, we work to BSI, which is British Standards, and there are specific rules that you need to know for British Standards. A common exam question would be to spot the mistakes or identify what's wrong with the drawing. So you need to know what to do correctly in order to see what's wrong in the exam. So there shouldn't be any more dimensions than necessary. This is something that a lot of people caught on to when they were doing their National 5 assignment. If you add too many dimensions, you can lose marks for over-dimensioning the product. So, for example, if you put a dimension on the elevation, you don't need to put the exact same dimension on the plan because it's already there on the drawing. Dimension should always be in millimetres, but you don't have to write millimetres at the end of the measurement. Instead, you would just write it in its simplest form. So, for example, 20, not 20.0. Try not to cross projection lines. You're wanting to make sure that your dimensions are as neat as possible. So we don't want them to be inside the drawing, and we don't want them to be kind of crossing lines that they don't need to necessarily cross. This is just another example of dimensioning to BSI. So you can see that the edge of the dimension lines does not touch the part. Instead, there is a gap here, so it doesn't run all the way into the line. The arrowheads are filled and they are pointing out the way, and the number is on the top of the line. Now, drawings should be able to be viewed either by the bottom of the drawing or by the right hand side of the drawing. So you have to make sure that the actual number can be seen either from the bottom or from the right. So there's different dimension types that you need to know. Some of these would have been covered in National 5, also they would have been covered in practical woodwork if you've done practical woodwork. Others may be new. So vertical, basic dimension that goes up and down, horizontals, left to right. So they're your basic dimensions. You've got the diameter, which is the circle with the cross through it, and then the number. So the circle, the diameter is from one side of the circle to the other. Circles will always be diameters and not radius, with the exception of sometimes in the exams they may give you a kind of radius in order to kind of trick you, and making sure that you, when you're doing the drawings, that you do it as a diameter. Remember that in terms of the assignment isn't to BSI standards. Normally the sketches they will do, and they will try and do things just to trick you. So for example, task 3 this year, for the National 5, you had to do the scooter stand. There was some dimensions that were through the actual object. You wouldn't do that. They're purposely doing that to try and trick you. So circles will always be diameters. The edges of a curve will always be radius. So R and then the number. And then you've got angular. So figures on this dimension should be positioned so that they can be read from the bottom or the right. So anything that's angular would have just the degree and then the arrowheads. Now, with your horizontal and vertical dimensions, there's two ways that they can be laid out. So the first one is the parallel dimension, and that means that they have the same datum point or edge. So you can see here the line is the exact same and they're all running off of this one datum point. The other is chain, so they are going edge to edge to edge. So with parallel dimension, it can take up a lot of space, because the more lines you've got, the further out this is going to be. With chain dimensioning, it's all on the one line, so it's taking up less space. However, it can lead to more errors because you're having to try and work out specifically what line it leads to. So if you have lots and lots of lines and lots of chain dimension, it can sometimes get a little bit confusing. So the two you would need to know and identify is parallel and chain. Now, dimensioning a hexagon, there's two ways that you can do it. So you can either do it across the flats or across the corners. So across the flats is from one line to the other, and across the corners is from one point to the next point. So when dimensioning a hexagon, you'll either have AF or AC. Exam question would be, what does AF stand for, or what does AC stand for? Or how, like, the two ways to dimension a hexagon. So across the flats and across the corners. When you're dimensioning a square, obviously all edges of a square are the same size. So with the square, you would have a kind of little square and then a number, and that number shows that every single side of this square is 15, so it's square 15. This is new to hire, so in terms of ellipse shapes, you can have the major axis and the minor axis. When we're working out tolerances later on in the year, you'll find out more about this information, but just know that the major axis is the longest distance along the centre, and the minor axis is the smallest distance. Again, it says you'll be able to identify or measure this. You'll be able to identify if it's a minor or a major. In terms of measuring it, don't worry, you don't know that just now, but you will learn it when we start talking about kind of tolerances. Last but not least is we were introduced to threads and like screw threads and metrics. So in the last slides, so the last dimension that you will need to know is how to read metric screw threads. So the M is for metric, and it's used to show the dimension of the thread that has been cut, and this can be used for both external and internal threads. So as you can see through here, there's a couple of different ways that you might see it. So you might just see the M6, which would be the metric thread is 6mm times 20, so it's 20 deep. M6 times 20 deep, M8 times 30 deep, or you might just see M8, and that just shows that this thread here is to an 8 diameter. So those are the dimensions that you need to know for higher graphics. As I said, a lot of them are covered previously. Even in first to third year, you might have came across a few of these dimensions. I'm sure you also learn about different kind of diameters and radius and things like that in math. So you might know some of the information previously, but I'm just asking that you please take all the notes that you need, keep them somewhere safe, because again, might not see you till August, and I will hand out some worksheets to go along with the information. Thank you, bye.